Now we're on exercise number 2. I am going to try and make a standing wave. In the same setup, there's supposed to be a person over there holding the end of the spring, but there's no person. I just attach it to the leg of a table, which it works perfectly fine with or without a spring. So what we're going to do now is see if I oscillate it at certain frequencies, if I can get a standing wave. So let me just try a couple different frequencies. Okay, 1, 2, okay. You see how there's 3 segments? I've got a standing wave right now. 1, 2, oh, actually there's 2. So I am in the second harmonic. There's 2 peaks and troughs, and there's 3 nodes and 2 antinodes. So I'm in the second harmonic. And you can see basically how fast I am wiggling it back and forth. Now let's actually try to get the third harmonic. Now I'm not going to change the tension. If you change the tension, then it screws up everything. So right now I'm going to try and get 3. There we go. I've got 3 now. 1, 2, 3. Now am I swinging it faster or slower? And what is the wavelength? The wavelength is the length of one segment. For 3, the length of a segment, is it smaller or bigger than with 2 segments, with 2 humps? So right now I have 3 complete humps in there. It's 1 more than I did before. I do 1 more. So these are the questions you have to ask yourself about wavelength and frequency. You could probably tell if I was moving it faster or slower than the first case. Now what I'm going to do is trying to get 4 humps, or 4 humps in here. Let me see. Oh, I think I got it. Is that 4 or 5? I don't know. So from peak to peak, the peak to peak distance is the wavelength. So is that smaller or bigger than in the previous case? Is the frequency smaller or bigger than in the previous case? It should match exactly with the equations that you saw earlier, the V equals F lambda.